much, Jose. I'll take these away from you before you get hurt. Okay? So, 2 problems. These are both going to be a little bit trickier than the usual, but that's fine. You can put the homework in the middle of the table. After that, you're going to have an opportunity to just get some good practice time, get some feedback. Those of you that are missing stickers, there's an opportunity to earn more stickers today. Life is going to be good. All right, so I want you to have a quick strategy conversation with somebody near you around model problem number 1. You see this, and what are the thoughts?
It's a fraction for the baby at the top. And these are all complicated. Like these integrations are weird to me.
Homework pile over here. No, let's put the cups back the way I like them. You guys have something very specific you're working on. I'm really thinking this is the last. Might be one of the last days.
I like the
Prove me wrong. Prove me wrong.
Use the baby, the L and the big.
Okay. So I've heard some conversations that the baby should be the natural log of x. Now, if the baby is the natural log of x, you know you've done this right if you also see the derivative of the baby. Let's see. So if I decide that u is the natural log of x, do I have the derivative of the baby?
Yes.
Right, the derivative of the baby is 1 over x. I see it, it's there, this tells me I've made a good choice. So I would multiply both sides by dx, and this du is 1 over x dx. I saw a lot of folks that said, all right, so I'm going to rewrite this as cosine of u. But that x is in the denominator and the dx, well, that's kind of what this guy is over here, right? I could imagine rewriting this if I needed to as 1 over x times cosine of ln of x dx. So I've got cosine of u du. Is there anybody in the house that isn't 100% okay with what's happened here? Everything's good? Okay, Mariah, now what? You got me there. What would you do from here? I want you to be careful. We are going to integrate, but not quite yet. There's something really important that we've forgotten about. What's the thing that we forgot about, Jonathan? Not the antiderivative. That's what Mariah just said. Mariah, what's the thing? What's the thing that we're forgetting about? Giselle, help her out. What's
the
the
limits
thing?
of integration.
You've got to change. Right. The idea is you've got to change everything. Everything that used to be in terms of x has to get changed over to be in terms of u over here. So if x was equal to e, what's the u version of that?
1 over e.
All right, I would do a little bit of side work. If x is equal to e, then u is the natural log of e, and the natural log of e is 1. U is equal to 1. Now I need to change the upper limit of integration. X equals e squared, so u is the natural log of e squared. This is one that you're less likely to just know off the top of your head. But a little bit of log cleverness goes a long way. A little bit of cleverness with the logs. Mariah, what you gonna do? I'm Mariah, no Amy, so sorry. Mariah's like, why me again? No Amy. Why? You're 100% right, it is 2, but how'd you get the 2? Robbie, how'd you get the 2?
You bring the 2 down. And
That 2 down,
ln of e, we know it equals 1.
right? If you're taking the natural log of something to a power, it's the same thing as saying 2 times the natural log of e. We've already established the natural log of e is 1. 2 times 1 has to be 2. Well done. U is equal to 2. Now we're like 10 seconds away from greatness. 10 seconds at most. Antiderivative of cosine of u du, everyone's going to tell me is? Oh, that was funny. One more time. Everyone's going to tell me that the antiderivative of cosine of u du is?
Sine of sine of u.
One more time. Antiderivative of cosine of u is?
Sine of u.
Okay, no one said negative sign. That's good. That's good. Okay, antiderivative of cosine of u is sine of u. Now evaluate from 1 to 2. Sine of 2 minus sine of 1. Don't try to simplify it. Don't make up some trig identity that doesn't exist. Don't call it sine of 1. Just leave it and move on.
What about the DU?
What about the du? Such a good, honestly good question.
B-spline.
No, not that good. What about the du? It went away. Ranbir, if I asked you what's the antiderivative of x squared dx, what would you tell me?
2x dx.
Well, yeah, buddy, one more time. What, the antiderivative of x squared dx? You wouldn't tell me 2x, you wouldn't tell me 2x, no. The antiderivative you would tell me
No, 1/3 x
is 1/3 x cubed
DU. Plus Charlie.
plus Charlie. Where'd the dx go?
Tells you what you
The
do.
better question is, why is the dx there?
It's constant.
It's not a constant.
Try it.
Why is the dx there?
Doesn't it tell you like whether or not like you get the derivative or the antiderivative?
It doesn't tell you whether to take the derivative or not, because that's what the integral is there for. This is telling you what you're taking the integral with respect to. It's saying x is the variable. So the antiderivative of x squared dx is 1/3 x cubed plus c. And usually here, no one stops to say where'd the dx go. But for some reason in the teenage brain, when we switch over, when we switch over to like use, right, it feels different.
Yeah.
But it's not. I'm still saying find the antiderivative of cosine of u with respect to u. And what's that antiderivative? Sine of u. Okay? Okay. Prepare for a mind-blowing experience on this next one. Most of you, I think, are ready for like 90% of the integration by substitution questions. This one falls firmly in this other 10%. So I'm going to have some strategy conversation with somebody near you. What would you do?
The baby.
So we could rewrite that.
The baby and then there's the square root.
But then the derivative of that.
Yeah, that's supposed to be the 2x. So 2x supposed to be
No,
the.
yeah, you can.
It's supposed to be the.
Oh, wait, no, you can't because you'll get 1, right?
With the dx.
But see, when you find
You don't bother writing
the
plus
you have to put in 2x, so 1 and 2x.
You multiply times 2x on both sides?
Take out the 2 and the 2 doesn't come.
You multiply times 1/6, Mariah. You obviously multiply. You ain't taking none away. Put it down.
How you gonna, you can't multiply by 2.
Why not?
Because you can't add to this, you can only take away from this.
Who said we add?
You're saying you multiply by 2?
All right. It looks like just about everybody has picked the same u. There's probably one natural choice for the u, and that u is x plus 1. Right? It's where the baby likes to live. The baby likes to live underneath the radical sign, in the denominator, in the exponent, in the parentheses, all the places. Oh, it's different. Let's see. If I find that u is equal to x plus 1, Daisy, what's your next move?
Then
You've identified the baby. The next thing?
you get the derivative.
You're going to find the derivative. You're going to find du dx. Du dx is 1. So I'm going to multiply both sides by dx. So du equals 1 times dx. Okay, not too bad. What I saw a lot of folks do is they said, all right, let me do a little integral here. The 2x, yeah, I'm not really sure what to do with that. Instead of saying cubed root of x plus 1, that's my cubed root of u. Instead of dx, if du is 1 times dx, then dx is really the same thing as du. We okay? Now, the best papers that I've seen out there, they didn't stop there. They knew that they also had to change the limits of integration. Maybe that's becoming a natural thing at this point, right? Over here, x is equal to 0, and the u version is If u is equal to x plus 1, x is 0, u is?
1.
U is. I always think that's so funny. If x is equal to 7, u is?
8.
Okay. U is 8. U is 8. And now we have a problem.
Oh my God.
There's a problem here.
You can't put an 8 into it.
What's the problem? This has never, ever, ever happened to us before. Jasmine, what's the problem?
There's still an egg.
There's still an x showing up in our problem. I don't like that. If we're going to do integration by substitution, everything has to be switched over to u's. I can have nothing with x's still. This puts us in that last 10%. This is where we need cleverness. Marvin, you've got some cleverness to share?
We plug in u minus 1, that will work.
Tell me where u minus 1's coming from.
U equals x plus 1, so you can subtract 1 on both sides.
If we've already decided that every time I write u, what I really mean is x plus 1. Marvin, one more time, what's your idea?
Subtract 1 on both sides.
Subtract 1 on both sides. Is that legal?
Yeah.
Okay, that's not like that illegal stuff that I've heard on the streets. So x is equal to u minus 1. I've already made this decision that this is the baby. Once I've made this decision, I can play around with this as I need to. To say, that means that x equals u minus 1, so guess what? I'm going to rewrite my integral. So I'm going from 1 to 8. 2 instead of x, call it u minus 1, times the cubed root of u du. Have we effectively switched everything over to u's?
Yes.
Then this is good. This is a successful substitution, whereas this guy is not quite there yet, because I still have the x's and the u's. So from here, I just want you to have a quick strategy conversation with somebody near you. What would you do to finish it off? What are the legal moves that are out there for you? Keep in mind, multiplication in the integrand.
So it'll be u to the 1/3.
Okay, yeah, I didn't do the 1/3, so you
All right, let's get some legal moves out there. I'll take legal moves. Anything from anybody, some legal thing that you can do. Eunice. I can distribute the 2. Okay, great. Now how many of you guys were going to distribute the 2? What's the other option with the 2?
Oh, factor it out.
Factor it out. Either way does not matter to me, but choose. I heard from Eunice, so I'm going to multiply that 2 in there. So I'm doing the integral from 1 to 8, 2u minus 2, u to the 1/3 du. Okay, good, not done. Good, not done. Need more cleverness. There has to be more cleverness in the room. Other things you could do. Adriana, what else could you do?
Can you distribute the u to the 1/3?
Can I? Is that legal?
You sure can.
I sure can. So now I've got an integral from 1 to 8, 2u times u to the 1/3. Check yourself in the algebra skills before you say anything here. 2u times u to the 1/3.
Oh, it's
I'm multiplying.
2u to the 4/3.
Bases are the same. Got to add those exponents.
2u to the 4/3.
So there's really a hidden exponent of 1 here. So 2u to the 4/3 minus 2u to the 1/3. I know. Oh my God, we're still not done. Still not done, but we are getting closer. More cleverness. Jennifer.
You subtract the exponent?
Subtract the exponents, like these guys over here. Not quite. These are not like terms. Remember that idea of like terms from Algebra 1? You can only combine them if the variable parts are exactly the same. But I've got u to the 4/3 power and u to the 1/3 power. They're not like terms. Other clever things that you can do. Legal, clever things. Jose, what can you do?
Factor out 2.
Okay, you could factor out the 2 if you want to. The other thing that you could do, maybe it makes life better. I wouldn't factor out anything with like a u out of that integral because that's not a constant. Maybe you'll get a little bit further by like thinking about this as two separate integrals, which is that thing you can do when you have subtraction. You just say, what's the antiderivative of 2u to the 4/3? Leave the 2 alone. The antiderivative of u to the 4/3. Let's see.
7.
Add 1 to the exponent first. So that's 7/3. Divide by the new power, 3/7.
Oh, okay.
Minus, that's the nice thing about subtraction and addition problems. I can just integrate now. Antiderivative of u to the 1/3. Add 1 to that power. Right? Divide by the new power. So you're really multiplying by 3/4. Now, integrate from 1 to 8. We are not going to do all the simplification. I'm so not interested in the simplification. I just want to get to that final, let's assume it's free response. Christian, what are you going to do next?
You have to change the, you have to plug in the original.
You're doing a definite integral here. With definite integrals, what I heard you say is you want to go back over to x's. With definite integrals, we're not going to worry about that. If you changed your limits of integration over to be in terms of u, don't switch back to x. All you've got to do, Christian. Don't listen to them, $10.
Plug in the,
Plug in that.
the new intervals.
Right, the limits of integration. Okay, so I'm going to have 2 times 3/7, 8 to the 7/3, minus 2 times 3/4, 8 to the 4/3. All that minus big parentheses, 2 times 3/7 times 1 to the 7/3 minus 2 times 3/4 times 1 to the 4/3. If you have nothing else to do and you want to spend the time simplifying, feel free. But I would prefer that we move on and spend more time in the calculus. Do I need you to know that 8 to the 7/3 is 128? That would be nice. I'm not worried about that. Everybody mostly okay? All right, so here's the thing. I'm gonna put, you okay? Okay, I'm gonna put 15 minutes on the clock. The person at the table who has bought the most cookies is in control of the cups. Or the person at the table who plans to buy the most cookies can be in control of the cups. You have 15 minutes, Robbie. I want to make sure you of all people hear this loud and clear.
15 minutes.
You have 15 minutes to get as many of these homework problems done as possible. I want you to use this time to get feedback and support